Hello everyone, welcome to Mission Trails Regional Park. We are at the Tierrasanta entrance to the park. This is if you exit Claremont Mesa Boulevard and drive east until the very end. This is where you'll end up. You may wonder what we're doing out here. Well, we are here to learn about relative dating and dating of geologic units out in the field. And so we're going to be looking at least 3 different sedimentary units, possibly 4 if we can find the 4th one. It's a little trickier to spot. And at least 2 different igneous units. This trip's going to include both stuff that we're recording today, as well as some photographs I've taken in other parts of the park that help illustrate a larger picture of how many of the natural features in this park came to be, and how you can use the skills you've learned about dating geologic units with respect to each other to learn a little bit more about that history. We're going to see some unconformities, some cross-cutting relationships, some conformable contacts, some laws of superposition out here. It is certainly not everything that you can date geologically, but it's a nice real-world example that will hopefully bring the field a little bit closer to your home and maybe inspire you to come out here and check out some of these things. All right, let's get started. So here we are crossing the first creek bridge. I always like to sort of throw in a little bit about what's happening now to give you some perspective on what we are looking at. And also clear up some common misconceptions, ones that I had when I was your age, honestly, and about your stage in my career as a geologist, taking some of my first geology classes. And that is that the dominant process here right now is weathering and erosion. This canyon is a relatively recent feature. You can even see at the head of this canyon a massive construction project. It could be argued that human construction activities are overwhelming any other geologic process here, but it is the Anthropocene. You can even see a lot of earth moving in a very short amount of time just up the way with that backhoe. But if we were just to look at, quote-unquote, natural processes, weathering is certainly the dominant force shaping the landscape here. All these canyons, even these flat-top mesas are all evidence of weathering having taken place here, and in one way or another. So like so sometimes people try to envision what this looked like when some of these were being laid down. We're basically right now surrounded by primarily sedimentary units. In fact, I saw some beautiful layering just below that bench up there. Wasn't sure if that was natural or not, probably a little hard to pick out. When these were being laid down, you would have been in a shallow ocean or a shallow bay. There might have been a sandbar somewhere off in that direction. You might have seen waves crashing. There might have been a massive river coming from up over that direction from the northeast. The Ballena River, a river during the primarily Eocene, played a major role in shaping this landscape and making it what it is. You'll see a number of conglomerates that are clearly tumbled river deposits, and we can actually use some relative dating to ascertain the ages of various events related to those river deposits. So this would have been, there might have been quite a strong current here at various times. You might have wanted a boat or at least a flotation vest or hopefully you're a strong swimmer. Not to mention there's probably some life in these seas. I have found fossils out here. And they, so, would have been a fairly dynamic place. Not to say it's not like it is now, dynamic now. Probably a bit warmer. Weather's absolutely beautiful. I love this weather, but just to start get you thinking about this. And over time, you would not have seen hills, you would have seen actually a fairly flat, level bottom as these sediments were being laid down. This erosion, all these hills, are the consequence of first wave erosion, creating what we call marine terraces, or flat-topped hills ending in cliffs. In fact, I'll point out some cliffs that were probably eroded by waves further as we go a little further. And more recently, as this land got uplifted, erosion started to carve some fairly deep gullies into it, one of which we're crossing now on this bridge. But these weren't there. These were all just continuously layered deposits, and you would have known what, it's actually this recent uplift that exposes all this stuff. There's plenty of places where there's deposits like this elsewhere in the world that, you don't see anything looking like this because there hasn't been any uplift. And I guess I should mention, yes, we're in an area that's currently undergoing tectonic uplift, fairly slowly, gradually, and that also explains a lot of what we see here and why San Diego geology is so spectacular.